So we're going to move on to our first presentation, Eliciting and Specifying Quality Attribute Requirements by Rob Wojcik. Rob Wojcik is a senior member of the technical staff at the SEI, a position he has held since 2004. In his current position, he performs training and consulting in software architecture technology and software architecture evaluations. And now I will turn it over to Rob Wojcik. Rob, all yours.
Hi, my name is Rob Wojcik. I am a member of the technical staff at the Software Engineering Institute. Today we're going to discuss quality attributes and quality attribute requirements. What are they? Where do they come from? I will talk about some of the problems that people typically have in collecting quality attribute requirements. And I will talk about something called the Quality Attribute Workshop, which is one method that's available to you for helping you to become better at collecting quality attribute requirements.
Okay, polling question number one, folks. When is the best time to specify quality attribute non-functional requirements? Option 1, after the software architecture is established. Option 2, before the software architecture is established. Or 3, quality attributes are not important. And we'll give you about 15 or 20 seconds for everyone to place a vote. And then once everybody's done wrapping up a vote here, we'll share the results to see what the winner is. And we'll proceed with that now. And 98.8% overwhelming says before the software architecture is established. Rob, I assume that's what you were looking for?
Yes, actually the best time to specify your quality attributes is before the software architecture is created. However, it's often the case that there's an existing system in place, and we might also, we must also be planning to modify that system or to migrate that system, and it would also be important at that time to establish what the current quality attribute requirements are for the existing system. Okay, so what are quality attributes? Quality attributes are measurable or testable properties of a system that are used to indicate how well the system satisfies stakeholder needs. So in some sense, we could just think of quality attributes as the non-functional requirements of a system. So I've given some examples here: availability, configurability, modifiability, performance, and so forth. Some people call these the Elities of the system. And I often joke and say that you could take your favorite word and put Elity on to the end of it, and you will probably find that in somebody's requirements documents as a quality attribute requirement. I think my favorite Elity from one of my past customers was the system shall have webifiability. So where do these quality attribute requirements come from? We always start with stakeholder goals and objectives and needs. Sometimes stakeholders, like your customer, for example, may tell you directly what their quality attribute requirements are. They'll say, I want my system to be highly modifiable, or I want it to be highly usable, or to have high performance. Sometimes your stakeholders are less direct about what the quality attribute requirements are for the system. They might say things like, I want to build a system and I want to make sure that the results are that we increase our market share, or that we want to modify our existing system and make sure that our company maintains a quality reputation, and so forth. So regardless of whether your stakeholders tell you directly what they think their quality attribute requirements are, or whether they tell you indirectly by maybe stating some specific goals and objectives. Our job when we're eliciting requirements is to figure out what those quality attribute requirements are. Because quality attribute requirements are a key input into the design of a software architecture. We say that the degree to which a system satisfies its quality attribute requirements is directly dependent on architectural structure. In fact, it is the case that if functionality were the only important thing when it comes to a software system, that is to have the system do the functions it's supposed to do, to have the system be functionally correct, if functionality were the only important thing, the truth is that probably just about any software architecture would do. The whole reason we have a need to structure an architecture, or one of the key reasons we need to structure an architecture, is specifically to satisfy the quality attribute requirements of a system. So consequently, architects need to have a solid understanding of the quality attributes of requirements for a system when they're going about designing the architecture for the system.
And polling question number 2. What approach does your organization use to specify quality attribute requirements? Option 1, we ask management what they think the system should do. Option 2, we discuss the system's quality attributes once the system is designed. Option 3, we use a method to gather the views of all our stakeholders early in the development lifecycle. And option 4, we don't worry about quality attributes. So we'll take about another 10 or 15 seconds to let everyone participate, and then we will share the results as last time. And we'll share the results now. So at 18.1% we ask management what they think the system should do. At 9.3%, we got discuss the system's quality attributes once the system is designed. The majority here think number 3, we use a method to gather the views of all our stakeholders early in the development lifecycle. And number 4, we don't worry about quality attributes. So Rob, I'm assuming number 3 again is what you were looking for.
Yes, I think number 3 is the best answer. Answer number 2, really, that is, it is not a good time to start discussing the system's quality attributes once the system has been designed. As Linda pointed out in her presentation, architecture represents some of the earliest and most important design decisions that we're going to make throughout the lifetime of the system. And the truth of the matter is once some of those key design decisions are made, they are very easy to change on paper. What's hard to change is everything else in the world that has aligned itself with those decisions. Once an architecture is established, many other things become established based on the architecture. Things like work breakdown structures, project plans, project schedules, organizational structure, team assignments, team activities, and so forth. So it's almost like little by little the whole world starts to revolve around the architecture. So once an architecture is in place and the system has already been designed, it's very, very difficult to change the architecture if you find out that the architecture is not suited to meeting certain qualities. So number 3 in this case is the best answer. Now, it's generally the case that people do a pretty good job at understanding the functional requirements and the design constraints placed on a system. Design constraints are design decisions that somebody has made for you and you are stuck with it. There's nothing you can do about it. So go ahead and develop a system for me. Just make sure it runs under Microsoft Windows. That's a design constraint. Or design a system for me and make sure it accommodates all of our legacy systems. That's a design constraint. So people are generally good at understanding functional requirements. They're generally good at understanding design constraints. they are absolutely horrible at understanding quality attribute requirements. And unfortunately, people go ahead with the designs of their system based on what they know about functional requirements and what they know about design constraints, and they often ignore quality attribute requirements, or they put up with quality attribute requirements that are vaguely specified. So what are some of the problems with the way people specify quality attribute requirements? Three key problems are the three I have here. One is quality attribute requirements are often specified in a non-operational way. And that is to say that I see the requirement, I have a sense that there's some important thing I have to design into the system, but I don't know exactly what it is, and I don't know exactly how to go about designing the system to satisfy the requirement. So for example, your customer comes to you and says, make sure you design the system so that it's easy to use. Well, what exactly does that mean? The system is an awfully large system. There's an awful lot of ways that people use it, and there's an awful lot of users. Do you mean all the users? Do you mean particular users? Or the system must have high performance. Does every aspect of the system have to have high performance? I can certainly design and build a system for you where I try to make everything in the system have high performance, but the chances are the customer is not interested in having everything on the system have high performance, but they have very specific ideas in mind. Or another example is the system must be portable. Portable to what? How do I design a system to satisfy that requirement? We call these types of requirements non-operational requirements. Second problem when it comes to eliciting and specifying quality attributes is people often argue over what name to place on a requirement, what quality attribute name to place on a requirement. So for example, years ago I had a customer that was designing a system, and one of the requirements for the system was the system must process 10,000 messages a second. So if I talk to one group of people within the customer organization, they would say, well, that's a performance requirement. If I talk to another group of people in the organization, they would say, oh, well, that's a capacity requirement. If I talk to another group of people, they would say, oh, that's a throughput requirement. And if I put those three groups of people into the room together, they would argue for 2 hours over whether 10,000 messages a second was performance, capacity, or throughput. And the truth is, at the end of the day, the system better process 10,000 messages a second, regardless of what you call it. But people will waste a lot of time arguing over what category to file the requirement in. Finally, another property is variations in vocabulary. So, for example, if I walk into a room and I say, please put your hand up if you think the system should have high performance, everybody in the room will put their hand up. The problem is everybody in the room has a slightly different definition of what high performance means. One person thinks it means less than 1 second. Another person thinks it means less than a millisecond. Another person thinks it means less than 10 seconds. And then I say, okay, high performance, let's go off and start developing the system. And then everybody does, with a different definition of what high performance means. And then I wake up a year later and discover that I've spent millions of dollars on the system, and I still don't have meet the stakeholders' performance requirements. So these are the three key problems that happens when it comes to eliciting and specifying quality attribute requirements. And there are different ways to get around these problems, but one way in particular, one tool that you have available to you is called the Quality Attribute Workshop. The Quality Attribute Workshop is a method that was developed at the SEI. It is a 2-day workshop that focuses on working with stakeholders to try to understand the quality attribute requirements of a particular system. Ideally, the Quality Attribute Workshop is conducted early in the life cycle before the architecture is created, From my experience, the truth of the matter is a lot of the quality attribute workshops I've participated in are for existing systems. And to qualify that a little bit, I'll have a customer that has a system that's been in place for years, and they are planning on making major revisions to their system. And what they would like to do is to understand what are the quality attribute requirements for the system today. And once they understand the quality attribute requirements today, then they look at the design of their existing system and try to figure out how to redesign the system to meet the current quality attribute requirements. So, but ideally, you would do this workshop as early in the life cycle as possible before the architecture is created. And the output of the quality attribute workshop is a set of quality attribute requirements that are characterized using something we call quality attribute scenarios. The quality attribute scenarios can then be used as input into the architecture design process. And I'm going to go through the steps of the QAW to introduce you to the method. There's also some technical reports at the SCI website that you could read about the quality attribute workshop, and certainly some of our courses cover the quality attribute workshop in more detail. Here are the basic steps of the method, and actually I should probably include a step 0 here. Step zero would be prior to the workshop when we meet with the customer and we say, you want to do a quality attribute workshop, what is the system that you want to focus on, who are the stakeholders that we need to have there, where is it going to be, when is it going to be, to arrange various logistics for the room and that sort of thing. Step 1 is when we actually walk into the room on the first day. And one of the very first things we do is we go around the room and we have everybody introduce themselves. A lot of times we find that the stakeholders that are in the room for a quality attribute workshop, some of them really have never met each other. Some of them did not even know that some of the other people in the room were even involved in the project or in the system development effort. And so one of the things about this workshop is that it's about opening the doors of communication between stakeholders. So we go around the room, each stakeholder in the room introduces themselves, says what their name is, what their job title is, what their role is related to the system that we're going to spend 2 days talking about. And typically, the number of stakeholders in the room varies. I've been in QAWs with as few as 8 people, and I've been in QAWs with as many as 45 people. Once we make introductions, then the facilitator of the QAW, would give a presentation of what is the QAW. Some of the people are in the room, they know that they're at a QAW, but they have no idea what a QAW is. So we'll spend about a half hour or 45 minutes walking the stakeholders through the QAW process, much like I'm doing right now with you. Once that's done, we move on to step 2. Somebody that represents the business office, the program office, the business manager, program manager, somebody that understands the business goals and objectives for the system will stand up and give a presentation about what is the context in which the system is being developed and the context in which the system will be used. What are some of the high-level requirements for the system, such as functional requirements, design constraints, and quality attribute requirements, and any sort of plans for development. Excuse me. And step 3, somebody that represents the architecture team gets up and actually in some ways gives a similar presentation. The architect will get up and talk about what does he or she think the context for the system is? What does he or she think some of the business goals and objectives are? The key requirements, such as functional requirements, quality attributes, requirements, and design constraints. Now you can imagine that between the two presentations, they're often not completely aligned with each other. So, for example, in the business presentation, the business manager might say, well, we're planning on having the first version of the system available in 6 months, and it will be running on 5 platforms, it'll only cost $50,000. And then during the architecture presentation plan, the architect might get up and say, well, the system, first version of the system will be up and running at the end of a year, and we'll be lucky if it's running on a single platform. So there's often slight disconnects between the two presentations, and you have to remember that these two presentations are being given to a room full of stakeholders who also have their own ideas about what the true goals and objectives are for the system and what some of the key requirements are and so forth. So again, a big part of this workshop is about opening up the channels of communication between the stakeholders. This workshop will help to reveal some of the assumptions that users are making about the requirements for the system. It'll help to reveal some of the areas where those assumptions conflict with each other. It'll help to reveal requirements, new requirements, requirements that conflict, requirements that don't make sense, requirements that are invalid, and that sort of thing. And specifically, we're focusing on quality attribute requirements. Now, during the two presentations, the quality attribute team, which typically consists of 3 or 4 people, one person being a facilitator and the other people being either scribes or note takers, before step 4, we are listening to the two presentations, and we are writing down anything that we hear that sounds like it might have an impact on the structure of the architecture. We call the things that have an impact on the structure of an architecture architectural drivers. So everybody in the QAW team is taking notes, and we're writing down architectural drivers, and at the end of step 3, we typically take a break, and the stakeholders go off and they get coffee and donuts, and the QAW team meets to come up with a consolidated list of architectural drivers. At the end of the break, we come back and we do step 4. And in step 4, we present the consolidated list of architectural drivers. We usually put them up on a screen in front of the participants, and we say, here is what we heard so far in the presentations that might be the architectural drivers for the system. Do you agree? Do you disagree? Are there things that you think we should add, or you think there are things we should remove? Because that list of architectural drivers will become the basis for scenario brainstorming. During scenario brainstorming, we go around the room and we ask stakeholders to give a very short scenario that characterizes some of the architectural drivers and quality attributes of the system. So, for example, we might see that performance was an architectural driver. So as a facilitator, I would ask the stakeholders for somebody to give me a very specific example of what high performance for the system means. And at this point, I'm only looking for a single sentence. That's, for example, one stakeholder might say, well, my brainstorm scenario is when the user pushes a button, the light turns on within 1 second. So we will write that down and then move on to the next stakeholder. Now, during brainstorm, we typically don't allow a lot of discussion. It's really a brainstorming session. There is no right or wrong scenarios. We try to go around the room quickly, and typically, say in a room full of 20 or 30 people, we'll have a chance to go around the room twice in about a half hour or 45 minutes and get probably 2 scenarios from each stakeholder. Once we have a list of brainstorm scenarios, while we're generating the list of brainstorm scenarios, the facilitator is looking for three general types of scenarios. We're looking for use case scenarios, or rather, everyday uses of the system. We're also looking for growth scenarios. These are scenarios that indicate sometime in the future that the system will be expanded to meet other capabilities or needs. And then we're looking for exploratory scenarios. Exploratory scenarios are scenarios that will probably never happen, but if they did, would cause the system to be stressed to its maximum. Here's an example of 3 brainstorm scenarios, an example of each type. So an everyday use of the system would be a remote user requests a database report via the web during a peak period and receives it within 5 seconds. A growth scenario would be I'm able to add a new data server to the system to reduce latency in the use case scenario to 2.5 seconds, and I'm able to do that within 1 person week. An exploratory scenario, and again, this is probably something that's never going to happen, but if it did, it would stress the system. And the scenario is half of the servers go down during normal operation, and yet the overall availability of the system is not affected. Okay. So typically, we are typing in all of the brainstorm scenarios, and we have access to a printer. We will print out the scenarios, enough copies for all the stakeholders in the room, and we will let the stakeholders stare at them for 15 or 20 minutes with 2 things in mind. One is scenario consolidation, in which where stakeholders will combine scenarios that are maybe worded slightly differently, but really saying the same thing, and then also to prioritize the scenarios. That's actually step 7. So here's an example of some scenarios that maybe should be consolidated. So in the event of a processor fault, the system can be rebooted, reinitialized. Second scenario is a processor failure or crash doesn't adversely affect any other components. The third scenario, software continues to operate even if the host fails. So we would ask stakeholders might identify these as being really saying the same thing, and suggest that maybe they be consolidated. So we open the room up for discussion, and we say, well, what does everybody else think? Should these be consolidated? Ultimately, the people that volunteered these scenarios in the first place will make the final decision about whether or not the scenarios are truly saying the same thing. If they are, they will be consolidated into a single scenario. If not, they will be left separately. The reason we do scenario consolidation in the first place is because in the next step, we're going to do scenario prioritization by voting, and if we do not consolidate scenarios that are saying the same thing, it will actually end up diluting the votes. So in step 7, we do scenario prioritization. So let's just say for the sake of discussion that we did scenario brainstorming and we generated 100 brainstorm scenarios. Well, in step 7, we are going to give each stakeholder a number of votes that's equal to 30% of the total number of brainstorm scenarios. So if we brainstormed 100 scenarios, I would give each stakeholder in the room 30 votes, which they can place on any scenarios they want. They can place all 30 votes on a single scenario, or they can pick 30 scenarios and place one vote on each scenario, or any combination that you can imagine. But they have 30 votes to distribute across whatever scenarios they think are most important. And we typically cast votes. First of all, vote casting is a public event. Everybody knows who's placing votes on what. And we typically vote in 2 rounds. So we'll go around the room once. Stakeholders will place half of their votes. And then we go around the room again, and stakeholders place the other half of their votes. Now, typically, when people are casting their votes and we're tallying up the votes, there is some discussion that comes up. A stakeholder might say, well, why are you placing 15 votes on that one scenario? Well, I don't even understand what that scenario means, and you're placing 15 votes on it. So some discussion ensues in the room, and as a result of the discussion, sometimes stakeholders will rearrange their votes a little bit in the second round of voting. Okay, now in step 8 is a very important step. This is where we refine scenarios. So far, the brainstorm scenarios are only a single sentence that kind of give us a little bit of an idea what a scenario is about. Scenario refinement allows us to fill out the details of each scenario. By the time we have finished step 7, it is usually about 12 o'clock or 1 o'clock in the afternoon on the first day. So when we begin step 8, we have about 4 hours left during the first day to do scenario refinement. And it's very typical that in the 4 hours at the end of the first day, that we will only be able to refine 4 or 5 scenarios. It usually takes stakeholders a little bit of time to get warmed up to the idea of, first of all, what is a scenario, and then what is scenario refinement all about. Usually they get better at it with each refinement with each scenario, and by the time we come back during the second day, we continue with step 8. They usually get a little bit faster. It is very typical at the end of a QAW to have somewhere between 10 and 15 scenarios refined. I think the Olympic record for scenario refinement is probably 21 scenarios in 2 days. But a typical refining a scenario, quality attribute scenarios have 6 parts. And I can only put so much on a slide, so you're going to see these 6 parts spread across the next 4 slides. But actually it works out well this way because it kind of shows how we refine the scenarios step by step. So what we start with is a big table that has a number of rows in it. Here's the first 3 rows of the table. Typically, the table will be empty at the start, and it'll be displayed on a screen in front of all the stakeholders. We will take the top voted for scenario, the short description, and we will insert it in the first row of the template. So here's an example where a brainstorm scenario that says the track capacity is saturated during peak operations over a large size theater and degrades in a predictable and useful manner. So we insert that into the template on the screen in front of all the stakeholders, and we ask them, what do you think the business goals and objectives are associated with the scenario? And usually some discussion ensues. In this case, the stakeholders said, well, we think this scenario is all about mission effectiveness. The next thing we'll say is, what do you think the key quality attributes associated with the scenario? And in this case, the stakeholders said performance and scalability. So now we're starting to zero in a little bit on what the meaning of this scenario is, and actually the next rows in the template help us do that even more. So for each scenario, we're going to ask, what is the stimulus related to this scenario? And again, this is up in front of all the stakeholders, and there's some discussion about it. And in this case, the stakeholders said, well, the stimulus is some resource capacity is saturated. And we don't necessarily do each row in the order I have shown. Personally, I do stimulus first, followed by response measure, and then I do the other three, artifact, environment, and stimulus source next. But I'll just go through through this quickly. So we got a stimulus of resource capacity is saturated. A response that I desire from the system is do appropriate throttling and also request for or release resources. And the response measure is some kind of predictable behavior as deemed appropriate for whatever platform the system is running on. The environment, I think you can think of the environment as some kind of preconditions for this scenario. In other words, here's some preconditions. If these preconditions are met, then you should think about the scenario, what the implications of the scenario are. If these preconditions are not met, then it's not really worth considering the scenario. It would be nonsensical. Artifacts are any sort of system components related that the stakeholders think might be related to the scenario, and stimulus source is what actually caused the stimulus in the first place. Now, while we're filling out these scenarios, there's a lot of discussion that occurs. Questions come up. We would record any questions that come up. Issues are identified. We record any issues that come up. But we do this, so this is one complete scenario. And this is called scenario refinement. So the last 4 slides are all the things we do to refine a single scenario. And we're going to do this one at a time from step 8, from the end of the most of the afternoon on the first day and the entire day on the second day. One at a time in order of priority. And that is all I have to say about quality attributes in the quality attribute workshop today, and I'll be happy to take a couple of questions.
Okay, thanks, Rob, for your presentation. So now we're going to put Rob in the hot seat, make him put on his consultant hat, and ask some questions. And question number 1 from Ed asking, would you conduct a QAW along with defining the functional requirements of the system with the same stakeholders?
I would, if I understand your question, it sounds like you're asking me if I would, in the same room, do both the functional requirements elicitation and quality attribute requirements elicitation. And my answer to that is no. I would personally not do that, and I doubt anybody else at the SCI would do that. In all honesty, I personally prefer to do, I like object-oriented analysis in design. So what I tend to do is I'll do some context diagrams and some use case analysis first to try to understand some of the major functions of the system. Once I understand some of the major functions of the system, then I would do something like a quality attribute workshop to start zeroing in on the quality attributes related to the major functions of the system. But no, I would not try to accomplish both in the same room at the same time.
Okay, next question from Ayub asking, are we talking about the client-side architect or the development team architect?
Actually, I think it can be both. I mean, both sides of that equation have stakeholders. Both sides of that equation have quality attribute requirements. And I'm not sure if it would be appropriate to have them all in the same room at the same time, or to have two different quality attribute workshops. That would probably be determined on a case-by-case basis. So I would say both.
Okay, Maria would like to know, are these architectural diagrams typically referring to current state?
I'm not sure what you mean by these architectural diagrams, but in general, I think architectural diagrams can refer to a number of things. So, for example, I might want to have architectural diagrams that show what is the current design of the system, and I might also want to have architectural diagrams that show me what I want the design of the system to look like in a year from now or 5 years from now, and then use the two diagrams to come up with some sort of migration plan, how to get me from the current state to the future state. But architectural diagrams really can represent any point in time. If I'm designing a new system, well, my architectural diagrams are probably, they're showing me what I want the first and future state of the system to be.
Okay, Mike would like to know, how many QA scenarios are typically developed and prioritized for a system of moderate size? 10, 100, 1,000?
So that's a really good question. How many of these quality attribute scenarios? So I'm going to answer this question because it's important, and I'm going to run over a minute. I hope that's okay. I'll do the best I can. But the truth of the matter is that, first of all, a while back a long time ago, I had a customer, and we did an RFP. In the RFP, we had 125 quality attributes. And for each quality attribute, we had somewhere from 1 to 10 scenarios associated with each quality attribute. We sent those proposals out to the vendors. The vendors sent back their responses, and we evaluated each vendor proposal against every single one of the 125 quality attributes and every single one of those scenarios, and it took us weeks and months to do that. And looking back on it, it was the biggest waste of time of my life. And at the time, and that was quite a long time ago, we thought it was important to look at every single quality attribute and every single quality attribute scenario. And the truth is, not all quality attributes are created equal. Some are more important than others, and some have more of an influence on the architecture than others. So your job as the architect is to identify what are the handful of quality attributes that will have the biggest impact on the architecture, and you develop as many scenarios as you need to understand what the quality attribute is all about and what the impact will be on the system. Now, is it going to say performance is your quality attribute? Will you understand performance and the impact on the system after one scenario? Probably not. Will you understand it after 5 scenarios? I don't know. Will it take 500 scenarios before you understand what performance is all about and the impact on the architecture? If you have to do 500 scenarios to understand what the performance requirements are for this system and the impact on the architecture, somebody else should probably be the architect for the system. So you do enough scenarios to understand the quality attribute and the impact on the system, and then you move on to another quality attribute. But you should not be doing 10,000 scenarios to characterize the ones that will have an impact on the system. And that's all the time I have. Thank you very much. I appreciate your time today. Please contact the SEI if there's any questions I can answer.
Yeah, Rob, thank you very much. Great presentation. Lots of questions we didn't get to, folks. There's a Saturn LinkedIn group you can post questions to. Rob loves answering emails, so you can contact him. We're going to take a short break here. We'll start in about another 3 minutes, so we're going to get our next speaker ready, and we'll start right up at 2:15. Thanks, everyone.